Hey, welcome back to my channel. My name is Gina. Last week, we derived the Doppler Effect formula. This week, let's look at an example. A siren emitting a sound of frequency 900 Hz moves away from an observer toward a cliff at a speed of 20 meters per second. The observer is running away from the cliff at a speed of 5 meters per second. What is the frequency of the sound, which is the echo reflected from the cliff, that the observer will hear? Assuming the speed of sound in air is 340 meters per second. Let's draw a simple sketch. Here there is the observer, the runner, and here there is a car. This car is moving toward the cliff. It's moving at the speed of VC, C for car, and speed is 20 meters per second. And the observer, let's call it the runner, is moving in the opposite direction, and speed, ER, is 5 meters per second. So initially, the car is emitting a sound at a frequency of 900 Hz. And the cliff will perceive a different frequency and will reflect the frequency back to the car or the runner. And let's call this F prime, which is the echo. Then since the runner is also moving, so the observer, the runner, will perceive a different frequency. And let's call this F double prime. So we need to consider two steps. Step 1. We want to find the frequency F prime, that is the frequency reflected from the cliff. Which is the echo. A quick recap from the video from last week. We derived the Doppler Effect formula. F prime is B plus or minus speed of observer, plus for when the observer is approaching, and minus for when the observer is receding, divided by wave speed minus or plus Bs, where Bs is speed of source, and minus for when the source is approaching, and plus for when the source is receding, and times the original frequency. So in this first step, the observer is the cliff. The cliff is stationary, so speed of observer is 0. And the source is the siren or the car. The car is moving at a speed of 20 meters per second. So we can use this to find F prime, frequency of echo. It would be speed of sound divided by speed of sound minus speed of car. Minus here because the source, the car, is moving toward the cliff, then times the original frequency. Let's call this equation 1. Then step 2. We are going to find the frequency F double prime heard or perceived by the runner, the observer. In this case, the observer would be the runner, and it is moving at the speed of 5 meters per second. And the source is the cliff. And the cliff is not moving, so speed of source is 0. So F double prime would be the wave speed minus sign here because observer is moving away. Speed of observer, which is speed of the runner, divided by wave speed. and times the frequency of the echo, f prime. Then we can substitute equation 1 into the f prime. Then we get b minus speed of the runner divided by b times equation 1, b divided by b minus speed of car times the original frequency. Then we substitute the numbers. Speed of sound is 340. Speed of runner is 5 meters per second divided by 340. Then times speed of sound 340 divided by 340 minus speed of car, which is 20 meters per second. Original frequency is 900 Hz. So we get the frequency perceived by the runner is 942.19 Hz. And that is the end of the video. If you have any questions, feel free to comment below. If you like my videos, please like and subscribe, and I'll see you in the next video.